So today we'll start in our traditional manner with just running quickly through the agenda. Myself and Connor will be your presenters today. And then the product that we're going to be talking about today is Assemble Connect. So I'll give a brief overview, and then we're going to step right into McCarthy's use case. From there, we'll dive into Q&A, and just based on the content Connor has shared with us, I have a feeling we're going to spend quite a bit of time with questions. So I'm excited to get to that point. So go ahead and jump right in. I'm Tim Kelly, the product manager at Assemble Systems. I actually come from the commercial construction space at a general contractor for a number of years before Assemble, user of Assemble and other construction technology. My role there was in both pre-construction and in construction in VDC. And prior to that, I graduated from Texas A&M with a degree in construction science. Connor, why don't you go ahead and introduce yourself?
All right, cool. How's it going, everybody? My name's Connor Burke. I'm a senior estimator working for McCarthy. Currently, I'm working out of our Newport Beach office. Anything from education work to commercial, healthcare, parking structure, kind of whatever the pre-construction department needs me to do. That's what I work on. I graduated from Cal Poly San Luis Obispo early 2014, and I've been working with McCarthy ever since, so a little over 3.5 years now. And then time working with Assemble, I've been working with Tim and their team now for probably the same amount of time, about 2.5, 3 years. And my day-to-day is pretty simple. I can help out on conceptual estimating, GMP budgeting, pursue presentations, but my true bread and butter is self-performed concrete. That's what I work on primarily, and excited to be here today.
Awesome. And just some other news. You recently shared with us that you're going to be full-time on the job site. And speaking of that construction, it sounds like a lot of really early mornings, I'm betting.
Oh yeah, that's going to be a different time zone for me basically to wake up in. But no, it'll be good. And ironically, the project that we're doing the case study on today is the one I'm going to go work on the field with. So it's true cradle to grave approach to pre-con and then field operations.
Yeah, I do. I appreciate when organizations do that sort of thing and give you the opportunity to take a project from beginning to end like that. So that's awesome. All right, so jumping in. For those of you that aren't aware of Assemble, what we do, Assemble is a cloud-based system that allows you to consume model data and other information, the graphics and the metadata behind it into our cloud environment. And with our application, you're able to manage, condition, and change the data as needed, organize it in a way that is consumable, and ultimately share that across your project team. So specifically today, we're going to be talking about a step beyond that, actually a direct connection into our database. So with that piece, I'll dive into that in just a moment. Prior to that, I'm going to let Connor talk a bit about McCarthy.
Cool. So just kind of wanted to give you guys a little overview on McCarthy and our company and what we do. We're based out of St. Louis, but we have 15 divisional offices around the country. Depending on that division and where we're working in, kind of dictates what types of projects we work on. So commercial, healthcare, and education, we do nationwide, but depending on where you work, so Southern California, we also do parking structures. Our Texas group does civil, our Southwest Phoenix group does solar. So it just depends on the market that we're working in, what types of projects we'll be working on primarily. But some more general information about us. We're a company that's been around for over 150 years, fully employee-owned company. That buyout happened in the early 2000s, I think 2002. And then full-time employees, we're looking at around 1,400 across the country. So pretty big company. Cool. And then because we're kind of going down a virtual design and construction BIM webinar, I thought it was kind of appropriate to talk about some of the other VDC tools and techniques we use here at McCarthy. So this is just kind of a general overview, some pictures of what else we do. So we have our own in-house animators for pursuit animations and for virtual reality and augmented reality. So we'll use that for end users to give them an idea of what they're going to get before they purchase it. We in-house train our VDC managers who run coordination clash for us from pre-construction all the way to the field. We do our own laser scanning. We do model-based building layout for building footprints. We have our own drone in-house surveyors where we have a few drone pilots that can go out and actually fly to terrain and give us survey points. And, finally, we do some charity work as well. So we use 360 GoPros, put them on the back of trailers for construction sites, and actually give some children and some owners and a true virtual reality look at the construction site as it's continuing through the process. And finally, we do a lot of model-based estimating, which we're kind of calling continuous cost modeling. So just kind of an oversight of some of the other tools we use.
Perfect. That's a really good overview. And on your previous slide, you mentioned training, and I can certainly vouch for the training that I know you share across your company. I know you travel a lot to train different regional offices on all these systems, and I also know that I think just about all of our customers, if I were to look at the training project usage, you guys have more training projects and more usage within those than I think anybody else. So that's fantastic on your part and your team to kind of disseminate that information across the organization to other users. That's great.
Yep, do the best we can.
I'll talk about Assemble Connect as starting from, a lot of what we do at Assemble is talk to our customers, talk to our user base and those that want to use Assemble about what they need. And we do track all of the enhancement requests that come in or features that people want to see. And when it gets to Excel and how people work with Excel and their own templates, we have quite a few of them. Things that look like they want to export to an existing Excel template. They use Covey. They want to push that information directly into that sheet. Or they want to export a select group of items directly into a specific mode. They want to look at just exporting the summary, or they want to export multiple rows for the same instances with different properties, or they want to export formulas or use formulas in Excel based taking the total cost value, or calculated formulas with other values, or on and on and on and on and on. We have a lot of requests around integrating between Assemble and Excel more tightly. We do today have a current process that allows you to get the data, organize it, create views around it, export that into Excel, again, make changes there and import that back into Assemble. But if you're talking about a project template that your company's had in place for many years, or you guys have been working on developing a specific process for top sheet on bid day, or bid buy process, or any of those things that you're relying on the model-based information and other data you're associating with that, you want to streamline that process. So what it looks like today when you publish models into Assemble is we're hosted on Amazon, and so our database is on the cloud. So you have our Assemble Insight, which is a web application, is accessing that database. So when you go in and you click on a model in Assemble, it's going to go grab all the information out of a database, and then you're going to organize, group, sort, and filter. Connor will talk to you guys about that in just a minute. But you set that information up within Assemble, and then you save that out. And ultimately, you can export that to Excel, which is in kind of a raw data format. Our export template is the data organized just as you would see in the inventory in Assemble. And then you ultimately, most of those requests are about getting that data into a project template or some template that's already existing. And so with Assemble Connect, what we want to do is eliminate that interaction or reduce the need for that interaction to condition that template with the data that you need. So we're giving direct access from the database through a set of APIs from a plugin to Excel. So with that said, this is actually a template that I had previously. We're breaking down the project and looking at our baseline against current updates and variance between. And ultimately, the idea in this is that this is something Connor will be speaking specifically to in just a few minutes, so I'm going to briefly go through it. But what that plugin does is it allows you to specify in this case, the quantity property that you're interested in, and then what sort of filters or what information you want to grab that around. And so this is, mapping quantities is a big value in a lot of different spreadsheets, obviously, that you can drive other calculations. And in this case, I have a couple of filters here. I'm looking at variance between versions. And so for this number, my current update, my version is specified there. And then I have the E30 assembly code selected. And then ultimately that drives the rest of my workbook. And as I update my models, I can connect to the latest copy, or I can connect to any copies in between. And so I have that audit trail managed within this workbook that I had, before Assemble existed. Another format that you're able to go grab data in is just a raw report format. I can specify exactly which columns I want to do, how I want to aggregate that information, how I want it to display in a table here. And ultimately, I can also, so this is information that would be coming out of Assemble, but I can also connect it to other data sources. So this is information coming actually out of an Access database that the customer, in this case, was using to map it back to the equipment number tag. And so they're using the equipment number tag, looking at when these PNIDs were added or when they were removed. So we have some other information that we're collecting. And then the orange column in between is actually keyed in entries. So they're able to still work with Excel and the power that you have there just by keying it in. And as I'm kind of talking through this, I said another data source. These are actually mapped together. And so you have a connection of, you can run this report all at once. The idea is that you can go in, and this is a really complicated dialogue here, but it actually shows some power behind it, is that you can actually create aggregated information or roll it up any way you want to see. You can specify how exactly to filter it out and then how you want to group that data. So now to step out of the weeds just a bit, what I'm going to do is turn it over to Connor to talk specifically about SOCA and their workflow that he's been using on this particular project.
Cool, perfect. Yeah, so taking a look at a case study where we've actually used this project, and it's one that I'm currently working on now. This is SOCA University, STEM in Residence. STEM is for Science, Technology, Engineering, and Mathematics. And I'll give you a little bit of a background on this project itself. So it's around $85 million, consisting of 3 buildings, but 2 types. So it's 1 STEM facility and 2 residence hall buildings. Primarily to this case study, we're going to be focusing on the STEM facility. Like I said, I work a lot on the self-performed concrete, so we've been using this mapping tool between Assemble and Excel to help expedite some dimensional information we need to help complete our concrete estimates. So the STEM building itself is 3 floors plus a basement on half the building. It's around 105,000 square feet. And it's located in Aliso Viejo, California. If you got people from across the country, it's kind of South Orange County in California. And I've been working on this thing for probably a year and a half, and the last 8 months I've been pretty intimate with coming up to permitting and contract buyout. So, when we're going through this case study, I kind of want you guys to think of those 3 bullet points that are up there, which is, what is this process doing to help us with pre-construction and taking off quantities? What it's doing is it's mimicking a traditional estimating process. So the typical idea of you have a set of plans, you color them up, you take the quantity to your next database. So for us, it's WinEst or Excel or whatever anybody else is using. It totally eliminates some of the manual entry, and because you're reducing that manual entry time, you're reducing your time necessary to complete an estimate. So, with that, we'll kind of go into the workflow. Okay, perfect. So thought it'd be a good way to kind of kick this off is big picture, right? So if you're working in a model-based estimating environment, there's a lot of pieces that need to go into this prior to even getting to the 2D and 3D and the Assemble Connect. And so I just kind of wanted to give you guys a picture that there's, front end, you need to sit down with your design team and you have a conversation with them about expectations. And then you need to understand the level of detail where the model is going to be coming in. And you're going to be investigating the model. But what we're going to be focusing on today are just 2 major points, and that's the 2D, 3D integration to the Assemble Connect database, which is Excel. So if you look at the blue and the red that's coming up, the blue is basically going to be the first part of the case study, which is, hey, I got information in Assemble, and I want to be able to classify it and kind of manipulate it into Excel. But the red on the top side is, before you can even start exporting information to Excel, you need to understand what you're looking for. So for us, the example we'll be looking at is concrete beams and a concrete structure. I'm looking for dimensional information. I'm looking for not just what the cubic yardages are that Assemble's telling me I have, but I'm looking for the length of a beam, the depth of a beam, the width of a beam, because ultimately I'm going to use that dimensional information to calculate things that aren't modeled, like formwork or shoring, scaffolding, stuff like that. So depending on what I need to pull out of the model is ultimately what's going to lead me to which cells do I need to map in Excel and what's the best way for me to expedite this whole process. So with that, I think we can kind of jump into. Oh, yeah.
Absolutely. No, I'm going to go ahead and change over, and we're going to jump into a demonstration. But as we do, you mentioned this, and it's a strong point to re-emphasize when you publish your models and you're looking at model data. I like to continue to emphasize this, is that it's not an easy button that you hit go, and then you take those quantities and you dump it into your database for estimating. You're validating that. You're making sure the numbers are good. You're verifying it against the drawings. You're doing that validation process. So, we will always want to make sure we emphasize the fact that you're still an estimator. You're still going through the process to make sure that the information that you're getting from the design team is accurate and how you're going to do it.
Exactly. And what you're going to see here with the Excel mapping is that it's going to look like an easy button. I mean, you're literally going to ask it to calculate your quantities, and once it does calculate it, it looks like everything's done. But there's a lot of upfront work that needs to happen for you to be able to continuously use that workbook or that Excel sheet to your advantage. So kind of wanted to jump into a live demo. So I got, first thing I kind of want to show you guys is how it mimics a current estimating takeoff process. So if you guys have been working in Assemble before, you've probably seen these screens, which are pretty typical. So you have your calculated information on the left-hand side, and you have your model on the right-hand side. So what I used to do was I'd have Bluebeam open on a different monitor or OST on another one, and I'm validating the model quantity with what I'm doing in my takeoff. Well, with the new update that Assemble's rolling out, it's basically this concept where you have your sheets linked to the model at the same time. So if you guys know, when you use a Revit model, for example, it's parametric, meaning that if you draw a line on a plan, it's going to also ultimately draw a line in the 3D world and vice versa. So those are linked. And that's basically what they've done here is they've created a link between modeled information and the plans themselves. So if I go here, my example being I click on this roof, which is a roof slab, I can go down here to my sheets, and it's going to show me all the sheets that have been pulled in from my last publish. But what it's also going to do, which we consider reducing the amount of time you play Where's Waldo on a project, it's going to show me where those items that I've clicked are located on specific sheets. And that's really important because it helps me find stuff a lot faster than I would have had to have gone and had it open in Bluebeam, click the link, and then go to the page. This is all in one location, which allows me to basically have everything in one database. So if you look here, the top view, I zoom into my plan, you'll see that it is the same item, which is great for me because I'm doing my quality control and my QA all at the same time, because I can look at this 24,000 square feet and go, okay, what is it really taking off? Well, it's taking off all these areas, but it's also deducting out these penetration points. So I know if I need to go through and add a little extra to it or not. That's what this is doing. But in terms of mimicking a current estimating process, if I click on this slab again, I go to Properties. I'm going to go down and I'm going to actually color this slab to be a notice to myself that I've taken it off. I click Apply and Save, and what you're going to see is nothing, which is perfect, because what you have up here is the color shading process. So you click this button, as well as down here, and when you take off, you'll see that my model has been colored to basically map my planned takeoff. And the rule of thumb I got with this is if the model isn't gray at the end of the day, then I know I've taken off everything. So that's kind of the general link between validating and trusting the model information to the set of plans and kind of going back and forth. But I kind of want to go and show you a more in-depth example, and this is the one that's going to actually connect to Excel. So what we're looking at here is that same cast-in-place structural model, except I've gone through and I've basically filtered out all the information that I don't need while looking at self-performed concrete. So these are my beams. So I've turned off my floors, I've turned off the other models, columns, foundations. I am primarily looking only for concrete rectangular beams and nothing else. So I have all this information here. Now, what's important to note when you're doing this is that I categorize my information by levels. And this kind of goes back to, you got to be thinking about what dimensional information you want to extract out of Assemble early, because for us, when we do self-performed concrete, I know that my beams on level 1 aren't going to be the same price as level 2 because of productivities, because I have a different type of equipment that I need to rent to get to level 2. There's different variables that are going to affect the price. So I have to break up my model to represent how we're going to actually build it in the field. So it's mashing pre-construction with constructability, basically. So if I click down here, it's going to show me all the beams that are located on level 1, right? Pretty simple. And my grouping is by level because that's the way that we're looking at it. Now, the second thing I've done is I've gone to my columns up here, and I've put in the columns that have dimensional information that I want to pull out and use for my concrete estimate. So if I'm looking at this first beam right here, it's saying it's about 20 linear feet, telling me my depth and my width and my depth. And this is the type of dimensional information I need to plug into our system WinEst for it to calculate other areas of the construction estimate. So that would be formwork, that would be reshore, that's shore, anything else. I mean, you can go to the, calculated values, like every 16 inches on center, I need to have a snap tie. So we're using this information as the, the generator for the rest of the estimate. So what I can do now, again, back to that same estimating process that I've done before, I can click on a beam in the model. It's going to tell me it's a CB 18 by 32H. I go to my sheet. I want to know which sheet that beam is located on. So it's going to pop up. I can click this button right here, which is zoom to the extent of where it is. It zooms into where that beam is located. Now all I have to do is go down here, highlight all of those beams on the floor, change the color, and continue the process, right? So this whole thing takes a lot of time, but all I'm doing is validating that the information and the lengths and the dimensions that I'm receiving from the model are accurate, because you have to do the upfront work, because if you just start sending stuff to Excel and hoping it's right without validating it, you can get yourself into a lot of trouble. So I go through this validation process, and again, when the whole model's colored, that's when I know I've taken everything off and I've checked it. But the time-consuming part of this process is really this information. I have to, per floor, manually enter all of this information for just the concrete beams. This doesn't include the foundations or the shear walls or the decks themselves. So this takes a lot of time. I would say maybe an hour and a half to do all this manual entry. But we want to find a way to automate that process. And if I trust the information that's coming out of Assemble, then I don't need to go through and line by line manually enter this into Excel. So I'm going to pull up now just an Excel sheet, which has some calculated values built into it. Basically what I'm doing here is I'm trying to find out the square foot of unmodeled information, such as the soffit or the beam size or the square foot of the cut section of those beams. But I don't have any of this information in here, and the time it would take for me to do it all, probably an hour and a half. So what Assemble's done is they've created this plugin that's up top, and Tim kind of showed it at the beginning, how it works. But what this is doing is I configure a single cell to a model, and then I extract that information. So in this example, I'm pulling it from McCarthy SoCal, my username. I'm pulling from the SoCa project, the structural model, and the version number that I want to extract this information from. Now, if I go to the actual cell itself, and I go to map quantity, it's going to tell me what I'm extracting. So for this one instance, I want to know the count, the number of those concrete beams, the type, and I want it to be the 16 by 24B, and I only wanted to extract the information on level 1. And that's what each one of these cells represents, a different quantity it's extracting from Assemble. So this is the length, this is the width, this is the height, and I have it done for all of my different concrete beams. So instead of having to manually enter all this, oh, Tim, you got something?
I was going to say, that's right. Instead of, you can manually enter, or you can, open up the Excel export from Assemble and copy that whole thing in here and do a VLOOKUP, or there are a lot of methods that people have gone through, but the biggest thing here is when things change in Assemble, you've gone through and you've reorganized your types, or you've published a new model because the design team issued a bulletin, or something changed. And when something changes, you either again go back through that manual entry process, or you're doing that several steps to get to this point. And so go ahead, but I just wanted to input there that today you can export that information out of Assemble, but it's several steps to get to this spreadsheet that you have right here.
Yeah, exactly. That's a good point, because if you look at my column headers that I have up here, they're basically reflecting the same column headers that I have over here. I'm basically lining up my saved views, which is my beam comparison view, to match what I want my export to look like in Excel. The idea being I'm trying to get a little bit more intimate information than just lengths and cubic yardages. I'm calculating other areas, so I need to be able to pull this apart. So I'd say pre-work to get the cells up and running and linked correctly. It might take an hour or two, but here's the easy button part, and it's pretty cool. So I can just select all these cells that are down here, and I just click Calc Quantities. And what it's going to do, it's going to go to the links, and it's going to pull all that information out for me. And now in 2 or 3 clicks, I'm analyzing my square foot of soffit versus the square foot of deck that I have to have the forming systems up for, and the different type of jump jacks to go in between. Same thing with my beam size. And I'm doing this in maybe like a tenth of the time it would take. And the beauty of this is the next time that I get a new model, I don't have to remap these cells. All I have to do is configure the connection. I go down to my version, and I go to my next version. I press OK, and then calculate quantities, and it's going to pull that new information back over into this sheet, and then I can manipulate it any way I want to. But yeah, this is the connection we've been using as much as we possibly can once we saw the benefits of it moving massive amount of information into a template that we ultimately created a while ago. That's all I got, Tim.
It happened so fast that it's hard to kind of jump back on. I mean, the idea here is that it does happen so fast. And once you've done that conditioning and that setup, across the team, you're doing that. And this allows your team to very quickly manage information and assemble across your federated models, so all of the models, and then import that into individual tabs or however you want to break out the information. Ultimately, this provides a lot of flexibility for any of those property sets that you're managing, whether they're coming from the model or they're coming from assembled properties or other data sets, or altogether outside of either of those, and you're linking information in from, in your case, WinEst or whatever else.
Yeah, so it's important to note too that this is very specific to concrete, right? So you could do this with any values that are coming out of Assemble. So if you're at a conceptual phase and you're just looking for general square footages of walls, you could map it to extract that quantity. This is just trying to show that there's a lot of power and it can pull a lot of different quantities at the same time in a format that you guys are ultimately comfortable with setting up.
Well, as we kind of wrap that up and want to jump into the questions, before we do, I want to make sure that say thanks to Connor and McCarthy for taking the time to contribute